Chapter 5, Example 8. Consider the fuel economy model again. In 24-6. Sketch pictures as you answer these questions. What percent of cars get under 20 miles per gallon? It told us to sketch it. We always should sketch it first anyway, so let's go ahead and do that. There's 24. One standard deviation weighs 18, so 24 should be a little bit before it. And then I want to shade. So I put 20 right down there. That's all I need to do for the sketch. 20 minus 24 over 6 equals negative 0.67. You may recognize this value because we saw it in an earlier example, the positive version of it, positive 0.67, or look it up in the table. But this comes out to be z is less than negative 0.67 is going to equal 25%, 0.2500. Okay, so according to the normal model, we would expect 25% of all cars to get under 20 miles per gallon. An ecology group is lobbying for a national goal calling for no more than 10% of all cars to be under 10 miles per gallon. If the standard deviation does not change, what average fuel efficiency must be attained? So, 10% is the goal we're looking for. 10% equals 0.1000. So we want to look in our z table and get as close as we can to that. And that turns out to be negative 2.33. Take that back. That turns out to be negative 1.28. So we get negative 1.28 equals 20, because we want to have 20 is that goal. We want only 10% to be under that, minus x bar, which is our unknown, and the standard deviations remain the same. So you multiply now, subtract the 20, and then you have to take the divide by negative 1 to make that x bar positive. But we just do all that math, pretty basic calculations, and you get 27.68. So, according to the normal model, A, mean mileage, because that's what we just found. Mean mileage of 27 7.68 miles per gallon would be required to meet the new goal. Car manufacturers argue that they cannot raise the average that much. They believe they can only get 26 miles per gallon. What standard deviation would allow them to meet the only 10% under goal? We already know this has to equal the z-score is negative 1.28, so there's nothing new to do there. So we still want that negative 1.28, which is going to equal 20 minus 26 over the standard deviation, which is what we're trying to find. And remember that negative 1.28 is 10%, so I should be sketching this out. We'll go back and sketch the previous example out. So x bar, I know. Which is 26. And 1.2 standard deviations, maybe right about there. So I'm shading there. That's what I'm doing. You should always do that graph first. It really helps to do it before the problem, because you can see, it helps you know which, if your z-score should be negative or positive. I forgot to do it on this previous example. The directions definitely said to do so. X bar is what we were finding there, and we had 10% right there. Okay, so now we're ready to calculate. You need to multiply by standard deviation, so we get negative 1.28 equals 20 let's get my symbols in there, SD, equals 20 minus 26, which is going to be minus 6. Divide by the negative 1.28, and we get the standard deviation equals positive 4.69. Okay, so according to the standard, to the normal model, a standard deviation of 4.69 miles per gallon with a mean of 26 miles per gallon would be required to meet the goal. Yes, you have to have that according to the normal model in there. Otherwise, you don't have that fact in there that is not an exact calculation. This is an estimate. It's a prediction. What change in the fuel economy of cars would achieving that standard deviation bring about? What are the advantages and disadvantages? Okay, lowering the standard deviation would mean more consistent fuel economy. Okay, what are advantages? This is advantageous because it helps us meet the new goal. Okay, the downside is that it lowers the amount of cars with higher fuel economies because you're bringing everything closer, so it's far less likely to have a car with like 42 miles per gallon.